welcome to today's class.
Physics is all about measurement, measurement of physical quantities. And after every measurement, you have to put the unit. Without unit, you will not get the complete mark after measurement. So now we are doing dimension. Dimension is a representation of physical quantities in terms of mass. We use M for mass, length, L for length, and time. These three quantities, mass, length, and time, are the fundamental quantities we are going to be using in dimensional analysis. Mass, remember the unit of mass is kilogram, the unit of length is meters, and the unit of time is seconds. So we are using mass, length, and time in dimensional analysis. If you want to find dimension very easy, you have to know formulas and units. So we are going to look at the dimensions of some physical quantities. We'll start from the very little ones, the common ones, and then we'll move to other ones. We are starting with velocity. Velocity is displacement over time. Displacement is meters, time is seconds. So we can write the dimension for velocity as, remember meters is L, and then time is in seconds, T. So the dimension for velocity finally will be V is equal to, this is the dimension for velocity, Lt raised to power minus 1. What about acceleration? Acceleration A. Remember that acceleration, the unit is meter per second square. Good, because acceleration is change in velocity all over time. So the dimension for acceleration will be, acceleration will be Lt raised to power minus 2. Force is mass times acceleration. So we are combining mass, that's the, remember you have to write the units, okay? The unit is kilogram, unit of acceleration is meter per second square. So from this we are going to get the dimension to be kg is for m, meters is for length, and seconds is time raised to power minus 2. Once you know this one, that's the unit. Start from the formula for each of it. Once you know the formula for force as mass times acceleration, then know the unit. All you have to do is to transform it. Kg is mass, that's m. Meter is length, and time is seconds. Then you can get the dimension for force. For pressure, okay, for pressure, what's the formula for pressure? Pressure is force acting per unit area. Remember, the first thing to know is the formula. Now, what's the unit of force? Remember, force is kilogram meter per second square. Now, area all over, area is meter square. Once you know the formula and you know the unit, dimension will be very easy. Remember, this is kilogram meter per second square. Now we have this meter here and we have this meter here. So we are going to combine these two meters to get the meter square down has come up as this. Remember that When you have 1/meter square, from your indices is equal to meter raised to power 2. That is why we have this as pressure. This is for force and this is for the area. So now let's combine it to get the dimension for pressure. The dimension for pressure, okay, we can combine the formula to be kilogram. This is m raised to power 1 and this is m raised to power minus 2. So 1 minus 2, it will reduce to m minus 1 seconds raised to power minus 2. So let's now get the dimension. The dimension kg is for mass, meter is for length, and seconds is for time. So this is the dimension for pressure. Let's get the dimension for work. What is work in physics? Work is the product of force and distance. Remember, force have been a major key here, so you must know the dimension for force. You must know it. With it, you can get other ones easily. Remember, we're able to get out of pressure from force. That pressure is force over area. So work now is force times distance. So force is kilogram meter per second square. That's the unit. So you should not forget that. You should not forget the unit of force is a major key. Then distance is in meters. So we are going to combine it to have, we are getting the units of work now. Kilogram meter is 2, that's m square, then seconds raised to power 2. So we have gotten the unit of work as kilogram meter square per second square. So let's transform it to get the dimension for work. So let's get the dimension. The unit of work is kilogram meter square per second square, which is the same thing as joules. So kg is for mass, meter square is for length, and time now. So this is the dimension for work. Let's do for power. For us to derive the dimension for power, you ask yourself, what is power? Define power. Power is work done all over time taken. And remember that work is force times distance. That's the one we just finished. Force times distance all over time. So let's try, now that we know the formula, let's get the units of power. Remember, power is measured in watts, but we want to get the unit in terms of kilogram, meter, and seconds, the three standard, the three fundamentals. So remember that we did this and we got force as kg, meter, force as kilogram, meter per second square, and then we added that of distance to have it to be meter square. And now we are dividing by time, which is seconds. Remember that 1 over x is x raised to power minus 1. So that this particular x is going to come up here and we'll now have the unit of power as kilogram meter square. So when the seconds, the time will come up, we are going to have kilogram meter square and then seconds cube, so that the dimension for power will be kg is for mass, meter is length square, and seconds is t raised to power 3. This is the dimension for power. Now let's talk about those that have related dimensions. The major ones you ought to know. Know the dimension for force. Don't ever forget it. That force is kilogram meter per second square. And once you know it, the dimension for force is mlt minus 2. Now once you know that of force, another one I want you to note, very very important, is the dimension for work, because work and energy, they are measured in joules. They are the same. Work and energy, they have the same dimension. So there are the ones that once you know them, they can help you note other ones. And also note that force and upthrust, they are the same thing. Sometimes they will not ask you to state the dimension for force, then you'll be asked to state upthrust. Upthrust is also force, and they have the same dimension. Force, force and upthrust have the same dimension. So in any exam you are taking, have that in mind. And then work and energy have the same dimension because they have the same unit. So don't forget this. Then let's derive the dimension for density. Density. For density, we use the symbol rho for density. We use the symbol rho for density. Now, density is mass per unit volume. Mass of a substance compared with equal with the volume. So now mass is in kg and volume is in meter cube. So the dimension for density kg will give us the mass m, and then the length, which is meter cube, is L raised to power 3. So this is the dimension for density. Please like this video, drop your comments, and subscribe to this channel. This is the way you will encourage me to keep producing content. Please subscribe to this channel, and let's continue our class as we check for that of moment of a force. Now, what is moment? Moment in physics is the product of force and distance. Moment, you have to prepare yourself. You don't know the one that will come out in the exam. So that is why you have to know every bit of this and how to get at it. Moment is the product of force and distance. Force, remember we have gotten force before to be kilogram meter per second square, and now we have distance, which is meters. So if we combine it, we are going to have it to be kg meter square, then seconds raised to power 2. So we'll have the dimension for moment to be kg will give us m, meter will give us the length, and then we'll have the time. This is the dimension for moments. The next one we'll be looking at is momentum. Now, what is momentum? Momentum in physics is the product of mass and velocity. That is why I said you must know the formula. From the formula, let's get the unit. Mass, remember mass is kg, and then velocity is meter per seconds. So from this, we can get the dimension for momentum as mlt minus 1. Okay, let's get the dimension for impulse. In physics, what is impulse? Impulse of a force. Impulse of a force is the product of force and time. Impulse of a force is the product of force and time. Remember, force is coming back here. That's why I said you must know that of force. Please, if there is one thing you must know in this class, let it be the dimension for force. Because once you know it, most of them depend on it. From there, you can get the other ones. So now, force, remember, force is kilogram meter per second square times time is in seconds. So from there, we have, remember that now we have seconds raised to power minus 2 and another seconds, which will now make it to be kilogram meter seconds raised to power minus 1, because minus 2 and this one will give us minus 1. So finally, the dimension for impulse of a force, kg is mass, that's m, meter is length, and then time is t raised to power minus 1. This is the dimension for impulse of a force. So the next thing we are going to do is to deduce the dimensional formula for modulus of elasticity and coefficient of viscosity. From Physics 101 past questions, deduce the dimensional formula for A, modulus of elasticity, and B, the coefficient of viscosity. So we are going to deduce the dimensional analysis of this. Okay. Let's start with modulus. Modulus of elasticity is equal to the ratio of stress to strain. The ratio of stress to strain. Now, what is stress? Remember, this is under elasticity, the ability of a material to retain its original shape and size after being distorted by an external force. Now we are looking at the modulus of elasticity as the ratio of stress to strain. What is stress? Stress is force over area. Stress is force over area, and strain is extension over the original length. So we are going to look at, remember this one, extension over the original length. Extension is in meters, length is in meters. So this meters will cancel meters, will neglect this particular part because it will cancel out. Then the final thing we are now looking for is force over area, because this particular one will give us 1. It has cancelled out. Now what is force? Remember, see force coming back. That's why I keep telling you, know the dimension for force. All over. What is area? Area is meter square. Now, so we have your modulus to be kg meter per second square all over meter square. So we stopped at kg meter per second square. Now divide by the area, so we can bring up that area to be meter raised to power minus 2. Please don't forget it. So we are now having kg meter raised to power minus 1 by your indices times minus 2. That will give us kg meter raised to power minus 1, and then this is the seconds. So let's get the dimensional finally. For your modulus, we are going to have it to be kg gives the mass, meters gives the length, and then time. So this is the dimension for Young modulus. Please, if you have watched to this point, just drop on the comment section, yes, I'm following. Please comment, drop yes, I am following, so that I will know how many people that are following through the classes. And if you have any question, drop it on the comment section. We are just starting, and I promise you that you're going to score A in your physics exam. Just follow through the classes. It's a video tutorial. You can watch it anytime in the car, anywhere you are. Just follow through the classes and you will see how you're going to come out with an A. We are starting with the first topic, and that's how we'll be treating all the topics in Physics 101. Please follow through this class. And please, if you have not subscribed, just hit the subscribe button, and that is another way of showing appreciation, so that I'll be encouraged to do more. So let's get the coefficient for the coefficient of viscosity now. For the coefficient of viscosity, the first thing you will ask yourself, this is the coefficient of viscosity, what is the formula? The formula for coefficient of viscosity is the tangential force required per unit area times the velocity gradient. Why are we calling it velocity gradient? We are calling it velocity gradient because of this dx. This is what makes it the velocity gradient. So the coefficient of viscosity is force per unit area times the reciprocal, that's 1 over, that's the reciprocal of the velocity gradient. So we are going to transform this to get what we want. Remember, this is 1 over. So handling this part means that dx is going to come up. So that we'll have f over a times dx over dv. Remember, dx came up because of the reciprocal, that's 1 over. Remember, that was what we had. So handling this aspect transforms it into this. So the coefficient of viscosity will now be force times dx over area times dv. Once you get this, the other ones will not be an issue. Now remember, force have come back into play. So let's put back force as kg meter per second square. You see why I keep emphasizing on the force. Then because of this dx, remember this is distance, we are going to have the mass meter to be squared. So the meter is squared because of force times this. Then what about the area? The area now we have meter squared times velocity. Remember, velocity is meter per second squared. Meter per second. Velocity is meter per second, please. It's acceleration that is meter per second squared. So once we have this, okay, once we have this, we can easily get the dimension. We can easily get the dimension. Okay, let's transform it. But before we go there, you can see that this is meter and this is meter. So we have reduced it now. We have reduced it. Let's reduce it further. Let's reduce it further such that this meter is going to come up, is going to go up as m raised to power minus 1. Then we'll combine these two seconds together to get, this is 2, this is second squared, and then we have another seconds down, so which is going to come up. Let's combine the whole thing to get what we are looking for. Okay, remember we have, we are left with kilogram. Remember, the meter square cancel the other meter, so that we have kilogram, and this left all over the meter down, that's the velocity aspect that was remaining. So this one we are going to have kg. This meter here is going to come up here to be m raised to power minus 1. And now remember, this seconds raised to power minus 2 and this seconds raised to power minus 1, we are going to combine it together to get what we are looking for. And remember, this is minus 2, then this is minus minus 1, which is minus 2 plus 1. So that at the end we'll have our seconds to be minus 1. You see how we have ended up getting the unit. So now we have gotten the unit, we can now transform it into dimension. We are left with kilogram, this, and this. So we can now put the dimension to be the mass of this and this as our final answer. So our next class, we are going to look at uses of dimensional analysis. How to use dimensional analysis to find the unit of physical quantities, and how to use directional analysis to find the correctness of physical equations. Please watch out for the next video. the second part of this dimensional analysis, where we'll be using it to relate equations in physics